Hi, today we are going to see about PD compensation. PD controller. The additive combination of the proportional and derivative control action is known as PD controller. M equal to Kc into E plus Kc into Td into dE by dt plus M, or M minus M equal to Kc into 1 plus TdS into E. For a linear change of deviation E equal to Et, then M minus M equal to Kce into T plus Td. Deviation E is defined at time t, while the manipulated variable is defined at time t plus Td. So net effect is to shift the manipulated variable M ahead by a time Td, the derivative time. Proportional and derivative controller. It is a combination of proportional and a derivative controller. The output is equal to the summation of proportional and derivative of the error signal. The mathematical analysis of PD controller. In this, the output is directly proportional to the summation of proportional of error and differentiation of the error signal. And writing this mathematically, we have A of t directly proportional to dE of t by dt plus A of t proportional to E of t. Removing the sign of proportionality, we have A of t equal to kd dE of t divided by dt plus kp E of t, where kd and kp proportional constant and derivative constant respectively. The advantages and disadvantages of proportional and derivative controllers. Advantages and disadvantages are combination of advantages and disadvantages of proportional and derivative controllers. It should be noted that adding 0 at the proper location in the open loop transfer function improves stability, while the addition of poles in the open loop transfer function may reduce the stability. The words at proper location in the above sentence are very important, and it is called designing of the control system. That is, both 0 and pole should be added at proper points in the complex plane to get the desired result. Diagram of PD controller. Inserting the PD controller is like the addition of 0 in open loop transfer function g of s h of s. Activity. In this present case, we have taken the value of k equal to 5.8 and Td equal to 0.5. Its time response against step input is shown in this graph. You can compare figure with figure 1 and can understand the effect of inserting the derivative part in the P controller. The transfer function of the PD controller is k plus TdS, or Td of s plus k divided by Td. So we have added 1 0 at k by Td. By controlling the value of k or Td, the position of the 0 can be decided. If 0 is very far away from the imaginary axis, its influence will decrease. If 0 is on the imaginary axis or very close to the imaginary axis, it will also be not accepted. Root locus generally starts from poles and terminates at zeros. Designer's aim is generally such that root locus should not go towards the imaginary axis. Due to this reason, 0 very near to imaginary axis is also not acceptable. Hence, a moderate position of 0 should be kept. Generally, it is said PD controller improves transient performance and the PI controller improves the steady state performance of a control system. Thank you.